Good morning, dear students. Today we will discuss bivariate analysis. Till now we have discussed univariate analysis. Analysis means you are going to handle one variable at one time. Now bivariate analysis involves two variables at one time. And bivariate analysis comprises of two kind of tests. One is test of differences and another one is is related to the association between variables. So in this particular presentation we will just discuss test of differences. When we talk about common bivariate test, and for example if we have type of measurement as nominal data, and the group differences are like that difference between two independent groups have to be checked, or there are two categories in variable, then we will be using either Z test for two proportions or chi-square test. And difference among three or more independent groups means it would involve only chi-square test. Then when we have our data as ordinal, right? We have discussed chi-square test in our last presentation. That is why we are not going to discuss this here. And then when it comes to ordinal data means non-parametric test. That means whenever it is like differences between two independent groups are to be measured, we will be using Mann-Whitney U-test or Wilcoxon test. And when it comes to differences among three or more independent groups, that means we have three categories, then it would be like Kruskal-Wallis test would be used. And we have parametric test also for all the while same. When it comes to, till now we have discussed nominal data and ordinal data. Suppose our data type of measurement you can say is either interval or ratio, then we'll be using parametric test against these two non-parametric tests. And these parametric tests are differences between two independent groups would be checked by independent groups t-test or z-test. And when there is to be checked differences among three or more independent groups, then one way ANOVA would be used. In this particular presentation, we'll be discussing both the tests one by one. Type of measurement, difference between two independent groups, t-test or z-test. The only difference between t-test or z-test is when we have smaller sample size, that means up to 30, we will be using t-test, or if the smaller size increases above 30, then we will be using z-test. Difference between groups when comparing means. That means we are talking about t-test. We are talking about ratio scaled variable. That means we are talking about the data which is metric here. And t-test is generally used when groups are smaller and when population standard deviation is unknown. Z-test would be used when groups are larger. I just told you this thing. Let us discuss it with the help of proper steps, you can say. Null hypothesis about mean differences between groups. It would be like this: mean of group 1 and mean of group 2. These do not have any difference among each other, right? Null hypothesis is stated like there is no difference. So mean of group 1 minus mean of group 2 would be equal to 0 because they are the same. They do not have any difference, right? This is your null hypothesis. This is the formula for t-test. Basically mean 1 minus mean 2, like we discussed it here, and divided by variability of random means. If it is 0, that means you do not have any difference. But because we are generally proving our alternate hypothesis, that means it would have some value at least. So that is why we are going to conduct this analysis. Mean of group 1 minus mean of group 2 divided by variability of random means. We will discuss these with the help of proper formulation. How would you calculate these terms? Variability of random means, how would you calculate it? Let us see it with the help of this. You can even state formulation of t like this. Mean of group 1 minus mean of group 2 divided by the pooled or combined standard deviation, standard error of difference between the means. That is denoted by S and in the leg x1 bar minus x2 bar. The same thing, x1 bar minus x2 bar, right? And how would we calculate this particular term, the pooled or combined standard error? Let us see it. It is calculated as the whole square root of n1 minus 1, where n1 is the sample size for group 1, and S12, that means variance of group 1, S1 square, plus N2 minus 1 and S2 square. N2 is the sample size of group 2 and S2 is variance for group 2, divided by N1 plus N2 minus 2. N1 means again the sample size for group 1 and N2 is sample size for group 2, and that would be multiplied by 1 divided by N1 plus 1 divided by N2. That is again the sample size for group 1 and 2. So this is basically how you will be calculating pooled estimate of the standard error for both the groups. Degrees of freedom is very important here. How would you calculate it? N minus A, N minus K. N here is total number of number of sample size. For example, if you have 2 groups, 3 groups, 4 groups, you will be summing all the values. For example, here we have got 2 groups. So n is equal to n1 plus n2, sample size of 1 and sample size of group 2, and k would be number of groups. So here degrees of freedom would be calculated as total number of units in sample 1 plus total number of units in sample 2 minus 2, because we have got 2 groups. Next is type of measurement as interval or ratio scale, and difference between 3 or more independent groups. Here we were discussing basically difference between 2 independent groups. We just had 2 groups, so that is why we were using T or Z test, right? This was our null hypothesis, and alternate hypothesis would be mu1 minus mu2 is not equal to 0, the opposite of null hypothesis. Then this was the formula, this was the basic formula here, and we will be calculating this with the help of the values given. We just need 4 values, and with the help of that we'll be first calculating the pooled or estimates, pooled or combined standard error of difference between means, and means would be calculated in the same way. This is just the average, so we do not require a lot of values. We just need all the values of x1, all the values of x2, or we can have just mean value and number of sample size in both the groups. With that we can go with this analysis, right? It is as simple as it could be. Then one-way ANOVA. Here we'll be calculating difference between 3 or more independent groups. When we had 2 groups, we were going with t-test. Now we have got more than 2 groups. More than 2 means 3 or more groups. That means we'll be going with one-way ANOVA. Or we even call it as one-way analysis of variance. ANOVA is analysis of variance basically. Here analysis of variance hypothesis when comparing 3 groups can be like this: mu1 is equal to mu2 is equal to mu3. This is our null hypothesis, and at the time of alternate hypothesis we can just cross them up, cross these equal signs, and this is calculated as f is equal to, we calculate analysis of variance or say ANOVA with the help of F ratio, and this is basically variance between groups divided by variance within groups. Let us see how will we calculate variance between and variance within groups. There is a proper structure for that, and here it is. You will be calculating SS total, that is sum of squares with the help of SS within plus SS between, and we'll be calculating all 3 values like this. SS total basically is equal to summation of xij minus x bar bar, and the whole square summation is I is equal to 1 up to n, and j is equal to 1 is up to c. Here xij is the individual scores, is that the ith observation or test unit in the jth group, right? And this is your grand mean, mean after the mean, right? Mean of all the means. And then n here is I is observation, ith cell we are talking about, n is all the observations or test unit in a group. And when we talk about j is equal to 1 up to c, that means we are talking about columns, right? This was ss total, then ss within. You can see the formula is almost same. Here we were using xij minus grand mean, but here we'll be using here it was like grand mean, and here it was like for jth column, grand mean for jth column. All the values would be same here. And the same way, when we talk about ss between, this value would be replaced like this: xj, the mean minus grand mean, the whole square, and it would be multiplied by nj rather than summation from I1 to n, right? This is little difference, little different, because we are calculating the sum of square between the groups now, not within. So xj here is individual score for jth group, and x double bar is your grand mean, and n is your number of all the observations in test units. So here it is, ss total can be calculated as within, with the help of this formula where we are using xij, that means individual score minus grand mean. And here everything is same, the only difference is xij minus x bar j is used here, and x bar j basically is your jth observation ka mean. Then we'll be calculating ss between, like j is equal to 1 up till n. Till now we were discussing like j is equal to 1 up to cth column, but now it is up to nth column, because we are calculating ss between, so we do not need columns here. And nj, n means number of observations or test unit in that particular group, multiplied by x bar j minus grand mean and up to the whole square. After calculating all these values also, there's a lot much to do. Now ms between, that is mean square between the values, between the variables, between the categories, you can say between the independent groups, is equal to ss between minus c minus 1 divided by c minus 1. We'll be calculating ms within as well, and this would be like ss within divided by cn minus c. Over here it was like c minus 1, and when it comes to within, it can be written as c into n minus 1. Then f is calculated as ms between divided by ms within. We have calculated these values with the help of ss between and ss within. Now we'll be taking up these values and we'll calculate f ratio, that is analysis of variance, right? F is equal to ms between divided by ms within. That's it. Let us discuss some true false now. Number 1, business researchers frequently use cross tabulation techniques in data analysis. Is it? Yes. Cross tabulation analysis technique is frequently used by business researchers. You can say this is the most widely used technique in data analysis. So it is true. Second is, when the difference between two groups is measured, this is a form of bivariate statistics. Yes, when we talk about just one variable, it was univariate, right? When we talk about two variables, we talk about bivariate statistic. And then there are categories of analysis in bivariate as well. And this one is definitely the bivariate statistic. When the difference between two groups is measured, this is actually a form of bivariate. That's true. Third is a statistical test that is used often in business research tests, the difference between two groups in terms of some behavior. Yes, when you talk about statistical test that is used in used for test the difference between two groups in terms of some behavior, that's 100% true. Most of the tests are generally used for test of differences, as in to check someone's behavior, or maybe actually that is also someone's behavior if you are trying to check their behavior regarding a product. If you want to see whether they are buying the product or not, that is purchase behavior. If you want to see whether they continue the job or not, when their salaries are decreased or increased, or their work pressure is increased, that is also a kind of behavior, professional behavior. So many things are there. Everything you see is a kind of behavior towards something. So it is true. If a researcher is interested in whether males file work grievances more frequently than females, this is an example of univariate statistics. Here we are trying to compare two groups. The researcher says that whether males file work grievances more frequently than females, that means we are trying to compare two groups. That means we are talking about bivariate statistics. So it is not an example of univariate. So it is false here. Fifth is, a cross tabulation is a simple way to describe the relationships between two groups. Is it? Cross tabulation is a simple way to describe relationship between two groups. That's 100% true, and we use it most in our business research, basically. When we talk about business research organizations, when we talk about people in management, people of students of MBA, students of BBA, yes, this is the most widely used technique to describe the relationship between two groups. So this is true. Sixth is, one way to test the significance of contingency tables is by means of the chi-square test. Yes, this is. So whenever we talk about significance of contingency tables, we go with the help, we go with chi-square test. So it is true. Seventh is, to use the chi-square test, both variables in a 2x2 contingency table must be measured on a ratio scale. Is it? To use chi-square test, both variables in a 2x2 contingency table must be measured on a ratio scale. Frequency count of data that nominally identify or categorically rank groups is acceptable here. So if your data is on ratio scale, that is acceptable everywhere, but still we go with either nominal or categorical scale in case of chi-square test. So it is false. Next is the independent samples t-test. Test the differences between means taken from two independent samples or group. Yes, there are so many t-tests: dependent paired t-test, student t-distribution, and independent sample t-test. So when we talk about independent sample t-test, that means we are checking the difference between two independent samples or groups. So this is true. Some self-assessment questions. Number 1, explain what an independent sample t-test is and null hypothesis examined. What do you mean by independent sample t-test? You will be defining independent sample t-test in this particular case, and then you can give one example of null hypothesis. Independent sample t-test basically is to test the differences between means taken from two independent samples or groups. Like we just had true false as well on this particular thing. It is a test of hypothesis stating that the mean scores for some interval or ratio scaled variable groups based on some less than interval classified variables are not the same. Thus the null hypothesis would be mu1, mean of group 1 would be equal to mean of group 2, which is equivalent to mean of group 1 minus mean of group 2 equal to 0. That would be null hypothesis, and alternate hypothesis would be mean of group 1 minus mean of group 2 is not equal to 0. Okay. Second is, list the practical steps for interpreting the t-test results. How would you interpret the t-test results? So number 1 would be examine the difference in means to find the directions or any difference. You'll be checking the difference between two means of two groups, and then you'll see whether you'll be having positive difference, negative difference, or you can even state the things like that this brand is better than the other brand, or this brand has more sales than the other brand, like that also can be stated. Then second is compare or locate the computed test value. You have to do the calculations here. Then third is find the p-value associated with this t and corresponding degrees of freedom. P-value is to be calculated, like you will be calculating a critical region, and with the help of that you will be coming to know significance value. The difference, last is fourth step would be the difference can also be examined using 95% confidence interval. Usually we go with 95% confidence interval, but you can go with 99 or 90% confidence interval as well. So next is, third is discuss when a paired samples t-test is appropriate and give an example of when it should be used. Then we talk about independent sample t-test. These are basically used when two groups are independent, like the name is also suggesting. But when you talk about paired sample t-test, that means groups are somewhere related, right? Or you can say that two variables values are taken at different time intervals. For example, you might want to check a company's profit over 10 years, right? For example, you might check in 2010 companies profit were these, and in 2020 companies profit were this, and you might check whether there is a difference between the profit in 2020 then 2010, or you might check it yearly as well. You might want to check that whether company's profit has improved over a year or not, right? So that is a kind of paired sample t-test, because these two groups are related. Now you are comparing the groups on the basis of time, right? Then fourth is what is ANOVA, and when is it the appropriate statistical technique? What test is used to determine the significance? What is basically ANOVA? As the name is suggesting, it is analysis of variance and involves the investigation of the effects of one treatment variable on an interval scale dependent variable. It is a hypothesis testing technique to determine whether statistical significant difference in mean occurs between two or more groups. The first step, basically the F test is used for ANOVA model, right? We have discussed the F test. Like F test is basically you'll be calculating the variance between the groups and within the groups, and you will be using that to calculate F ratio. After calculating the F ratio, you'll be checking whether p value is coming under the significance level or not, and then you'll be able to decide whether like we have mentioned what test is used to determine the significance. We'll be using F test, F ratio you can say, and we'll be checking p value after that, so as to check whether the result are significant or not. You cannot just state the results without checking p value. That's it about bivariate test of differences for parametric test. In our next video presentation, we will be discussing these two analyses. Like we have just discussed difference between two independent groups in case of interval or ratio data, right? And that was your t-test. And we have discussed difference among three or more independent groups, that means ANOVA. And when it is about when you are going to use the same for a non-parametric test, you will be using Kruskal-Wallis test. We generally say there are non-parametric tests against each parametric test for the same comparisons, right? So these would be discussed in our next presentation. That's it. Thank you.